A transceiver in radio communication serves as a dual-purpose electronic device, combining a radio transmitter and a receiver within a single unit, facilitating the transmission and reception of radio waves, utilizing an antenna for communication purposes. This integration is often done to streamline manufacturing processes and enhance cost-effectiveness. The term transceiver extends beyond radio communication, encapsulating devices like optical transceivers for transmitting and receiving light in optical fiber systems, as well as bus transceivers for handling digital data transmission and reception in computer buses. Radio transceivers find extensive applications in various wireless devices, prominently in two-way radios for bidirectional person-to-person voice communication. Examples span from everyday gadgets like cell phones, which leverage radio waves to transmit and receive phone conversations via cell towers, to cordless phones with transceivers in both handset and base station for seamless communication. Moreover, land mobile radio systems like walkie-talkies and CB radios rely on transceivers. In the realm of data communication, wireless modems in mobile network devices such as laptops, pads, and cell phones utilize transceivers to exchange digital data with wireless routers. Additional applications include the use of automated microwave transceivers, called transponders, in aircraft. These devices, triggered by microwaves from air traffic control radars, transmit coded signals back for aircraft identification. Furthermore, satellite transponders in communication satellites receive digital telecommunication data from ground stations, retransmitting it to other designated ground stations. Historically, the concept of the transceiver emerged in the 1920s. Revolutionizing the industry by amalgamating the functionalities of separate receivers and transmitters into a single device. This transition paved the way for modern amateur radio equipment heavily reliant on transceivers. Despite this prevalence, there remains a demand for standalone radio receivers, particularly favored by shortwave listening operators. Analog transceivers employ frequency modulation for data transmission, offering a reliable communication method favored in emergency systems. While analog transceivers exhibit limitations in data complexity, they remain cost-effective and widely used in communities like CB and ham radio operators. On the other hand, digital transceivers transmit binary data through radio waves, enabling a broader range of data types, such as video and encrypted communications. A decapped integrated circuit of a transceiver is commonly found in handheld communication devices and radio equipment to extend their modem capabilities. Notably, on-die pass filters are observable in these circuits. In wired telephones, the handset encompasses the transmitter, for speaking, and receiver, for listening, collectively known as a receiver, despite both transmitting and receiving data. Conversely, in mobile and radio telephones, the entire unit serves as a transceiver for audio and radio signals. Cordless telephones integrate an audio and radio transceiver in the handset, while the base station houses a radio transceiver. If a speakerphone is integrated into the wired telephone or cordless base station, the base also operates as an audio transceiver. Comparatively, a modem functions similarly to a transceiver by sending and receiving signals, but employs modulation and demodulation techniques. Within Ethernet networks, various transceiver systems like MAUs for IEEE 802.3, as well as GBIC, SFP, SFP+, QSFP, XFP, XAUI, CXP, and CFP for different Ethernet configurations such as fiber optic gigabit, 10 gigabit, 40 gigabit, and 100 gigabit Ethernet are widely used. Given their ability to transmit information over airwaves, transceivers must adhere to specific regulations. The Federal Communications Commission, FCC, in the United States, oversees the usage of transceivers, ensuring they meet required standards and capabilities depending on their intended function. Manufacturers are obligated to comply with these regulations. However, users can modify transceivers to contravene FCC rules, potentially using them to broadcast on unauthorized frequencies or channels. Consequently, the FCC not only regulates the manufacturing, but also monitors the utilization of these devices.